In this class, I want to look at a very famous definition of economics. And from that definition, we should learn what economics is about. So it's a very important definition, and all the words in the definition mean something, as we'll see. The definition is the Robbins definition of economics. It says economics is a science which studies human behaviour as a relationship between ends and scarce means which have alternative uses. Put forward by Lord Robbins back in 1932. As we'll see in this class, we're going to talk about the words in the definition, because each of the words does a job and we need to understand what the words mean. So this video is about the words in the definition. So it says, for example, that economics is a science which studies human behaviour as a relationship between ends and scarce means which have alternative uses. And I've highlighted these in red. These are the important words. He's managed to squeeze lots of ideas into one definition. That's what makes it such an interesting definition. But now we need to go through it and look at the various words to decompose the definition in effect and look at the words and see what they mean. So we'll start by the first one. Economics is a science. Well, is economics a science? So-called neoclassical economics uses mathematical techniques to analyse economic relationships. If you look at economics on television, or economists talking about the economy or about welfare, whatever it is, there's an underlying theme or feeling that they are working to some mathematical model. It's true of students who study economics that life gets easy when we have some mathematics. We're able to understand the arguments clearer because we're able to specify them mathematically. But as we'll see in the definition, we are dealing with people, and people are not amenable to mathematical manipulation. So we have a contradiction here. We will see it as we go through the definition. But we're going to deal with mostly neoclassical economics in our study. And that's the type of economics, as we work our way through the syllabus, that's the type of economics that's widespread nowadays. It's got mathematics just lying under the surface. It's not quite explicit in what we're going to do, but you can imagine it being there subsequently. The neoclassical approach to economics attempts to use the scientific method. Now we need to work out, what is the scientific method? Well, it postulates a relationship between two variables. It says that A depends on B. Something depends on something else. Something is related to something else. It connects two things, two variables. It says when we see dark clouds, it's going to rain. We're connecting two things here. We're connecting the sight of the dark clouds and the possibility of rain. So we do it a lot. We do it in our everyday lives. We're always connecting things and drawing our own conclusions as to what's likely to happen. And economists do the same thing. We look at relationships, and out of the relationships we try to work out general rules, general propositions. So let's say we look and say every time the price of petrol rises, less petrol is sold. That seems reasonable. The price of petrol goes up, less petrol will be sold. Every time. Problem is, how do we know this? Well, what we'd probably do is collect some data. We would get some statistics, get some facts, look at what happens to the price of petrol as it rises, what happens to the sales, try to work out a correlation between the two, try to figure out if there is a relationship. We're collecting the data, but we're analysing the data to determine the relationship. And once we've analysed it, we try to generalise it. So once we've got an insight into something, the Holy Grail, what we really want to do is to generalise. And we'll see how that works in a moment. So, postulate a relationship between two variables. Every time the price of petrol rises, less petrol is sold. Let's break it down. Let's look at our sentence and see what we can do with that. Well, we've got every time. That's one part. Next part is the price of petrol rises. Okay, that's the second part. And the last part is less petrol is sold. So we've got 3 parts here. And I've underlined the 3 of them. Now what we need to do is we need to test this. So how we do that is we collect some data. We'd have to go around to petrol retailing stations and ask them, what happens when the price of petrol rises? Do you sell more or less? How much less? Is it a lot less, a little less? Is it worth taking into account? Then we analyse the data to determine the relationship. We have collected the data, now we analyse it to see what does the data tell us. And once we've found out that, we try to generalise. We say, we have done our tests. We've been to a service station, a petrol service station. We've asked, they told us when the price of petrol goes up, they sell less petrol. Now, can we generalise? We've only been to one petrol station, filling station. Can we generalise now? That's a fairly weak generalisation. We've only been to one. So maybe we should go to 100. That's expensive, time consuming, but we'd get a better insight if we did. So we have a trade-off between the cost of doing it, the time, the effort, against the value of the outcome. But really, the more we do, the better it is. And we should ideally pick the service stations randomly. Don't just go to the one down the road from you. They should be random, which may mean the one you pick is at the other end of the country. Maybe take you 2 days to get there. But scientifically, that's what you should be doing. Let's go back. Every time the price of petrol rises, less petrol is sold. The price of petrol has just increased, therefore less petrol is sold. That's our proposition. We're saying every time. Every time. But how do we know it'll happen every time? It might happen every time in the past, but tomorrow it may not happen. So again, we've got a problem. How do we know? We can't tell the future. We can't say every time. It'll definitely happen next week. We don't know what's going to happen next week. So saying it's going to happen every time, that's a big statement. But we could attempt to get there through something called the inductive method, or induction. Now there are steps in the induction that we can have a look at. This is called the principle of enumeration, the principle of counting up. I'm going to give you a silly little example here, just one I fell across when preparing this class. There are 6 sheep. Okay, 6 sheep. And I'm going to postulate by the principle of enumeration, all sheep have white coats, because I've seen 6 sheep. There they are. They've all got white coats. So now I can go, all sheep have white coats, because that's all I've seen. I've only seen 6. In my life, I've only seen 6 sheep. There they are, and they've all got white coats. Now, by the principle of enumeration, by the principle of counting up, I say all sheep have white coats. That seems reasonable. Except This sheep appears. This sheep does not have a white coat. Now I can't say all sheep have white coats. They don't. I have to change that. I have to change the all. I can't say all sheep. It's clearly not true. So I have to change the all to something else. And what I'll change it to is some. Some sheep have white coats. Now that is true. Some sheep have white coats. Some sheep have black coats. So we can't go with all. We have to change it to some. The principle of enumeration leads us to generalization. That's what we're aiming for. We're aiming to say all sheep have white coats, or all sheep have black coats, or every time the price of petrol rises, less petrol is sold, or we're aiming to generalize. That's the Holy Grail. That's what we're after. And we do this by induction. Let's have a look at how induction works. Let's say we have all A is B. So we're told all A is B. For example, every time the petrol rises, less petrol is sold. All A, every time the price of petrol rises. B, less petrol is sold. Okay, so there it is. We have a quantifier at the start, all, every time. The price of petrol, that's A, less petrol is sold is B. Now, we know that all A is B. Now we're told A. And if we're told A, therefore B. That's straightforward. If we have all A is B, and we're told we've got A, then we've got B. And we give these names. All A is B, we call it the major premise. Then A is the minor premise. Therefore B is the conclusion. So we've got this. And in the study of logic, we've got to all A is B through something called induction. We've induced it. We've looked at one and said all A is B. Well, A is B here, A is B over there, A is B down the road, A is B in the next country. Eventually we say, look, every time this arises, all A is B. So we'll say all A is B. We've induced it. We have looked at one, we've looked at two, we've looked at 1,000. All of them are saying the same thing, and after a while we say, look, all of them. As soon as we say all, we've induced. It's by induction. Now, having got this general statement that we've inducted, we can now deduce. We go, all A is B. Okay, so now A, therefore B. We have deduced. We can only deduce if we've got a universal statement like all A is B. We call that a universal affirmative statement. All A is B. All, universal. We have deduced from it, given this minor premise, and we get the conclusion, therefore B. Now there's much more for us to do on the Robbins definition, as you can imagine. I've just looked at the first part. Let's leave it at that and have a break. Please come back and get the rest of the Robbins definition. It is important. In the meantime, let's leave it at that and say thank you for watching.